All right, hello again, Wildcats. This is Coach Lamb, and I am coming to you to make you another video. Today we're going to be talking about chemical and physical properties and chemical and physical changes. This video should be used kind of as a review for you guys and to kind of help remember. There's going to be a lot of information covered in here, and we're going to put in a little video with it too. So let's go ahead and get started. First thing we're going to talk about is everything has properties. If it's matter, it has properties. This includes people, this includes things, some very common properties that you might understand, like you have voice, your height is one of your properties. Remember, a property is an adjective. Property describes the noun. In this case, the examples you can see on the slide is the properties describe the people. And so properties are adjectives. They describe the thing. You have unique hair color. You have a height that describes you. Your eye color describes you. Well, the same can be said about all kinds of different things. Properties. Matter has properties, and we identify things by its properties. Properties are usually things that are quantifiable. We can measure them and observe them. We use general properties to identify substances. For instance, you might say water is clear and liquid. Those are two physical properties that would describe it. Two basic types of properties are physical and chemical, which we've been discussing. The physical properties, these are the easier ones to identify. These are something you can use your senses in order to understand. You can see them, you can feel them. These are the characteristics you can describe without changing the substance. So you could, if I gave you a chair, you might tell me, just by looking at it, you could tell the color of the chair or the height of the chair. These are physical properties. Some common examples of physical properties, you have things like hardness, the texture, is it smooth or rough, the color, how something smells is a physical property, taste, its temperature, what its temperature is at room temperature. So these are all common physical properties. Some more example might be a little bit more fancy. You got viscosity, which is the resistance of a liquid to flowing, how easily does it move. Things with low viscosity would be like water, alcohol. Things with high viscosity would be like honey. So 6th grade science, you won't have to worry too much about viscosity, but you might get into that a little bit more in 7th and 8th grade. All right, then you have chemical properties. Chemical properties are characteristics involved when a substance changes its chemical makeup. You're only going to tell a chemical property when you put it through a chemical change. Some common chemical properties. If a thing is flammable, that's a chemical property. Does it rust? Does it create bubbles? Does a metal react with water? If so, that's one of its chemical properties, that it reacts with water. So we're going to look a lot at this. So we're going to look at the chemical and physical changes now and how you can tell the difference. Now, some of these slides you might have seen in your class already, but it's good to kind of go back over them. If you're wanting to follow along, do a little activity with the video, I wrote in here you could make a T-chart. And as you're making your T-chart, you're going to put physical changes on one side and chemical changes on the other. As we go through the presentation, feel free to fill in, and you'll have a nice big chunk of examples that you can go back and refer to of common physical and chemical changes. So you have physical changes. It's a physical change if something changes its size or shape. Dissolving is a common physical change. Let me go back, dissolving, like when you make Kool-Aid. You dissolve the Kool-Aid mixture and the sugar into the water. If you were to evaporate out the water, then you would still be left with the sugar and the Kool-Aid mix at the bottom. Dissolving is something that you talked about in 5th grade when you were discussing solutions. It's a physical change also if it changes phase. This is one that I think gives kids the most trouble. A phase change, you can see we have, let me pull out the pen here so I can write things. An easy way that I find to remember it is if it's a phase change, you see the letter P, it's a physical change. Phase change is when you have something freezing, boiling, evaporating, or condensating. Think of water. You have a glass of water. You put it in the freezer, it freezes. It's still made of H2O. It's H2O if it's ice or if it's liquid water, or if you've evaporated it and made it into steam, still liquid water. It goes up into the clouds and it condensates, turns back into water droplets. It's still H2O. This is why a phase change is a physical change, because the basic properties have not changed. It's not made of anything different. It's still the same stuff, still hydrogen and oxygen. Chemical changes. Chemical change changes the way the molecules link up. You're changing the atomic, not subatomic structure, but you're changing the molecular structure of the substance. And when you do so, you make a brand new substance. So physical change, it's the same stuff. It's still water if you freeze it or if you boil it. Chemical change, you're making something brand new. You're completely changing what the substance is. Things that are chemical changes are burning. Burning is a chemical change. If you have a temperature change without heating or cooling the item artificially, then that's a chemical change. We call this endothermic and exothermic reactions. Endo and exo, you've heard those terms before. You might have heard the term exoskeleton when you studied insects before, meaning their skeletons are on the outside. Well, exothermic comes from the word exo and thermic. So exos are for outside, thermic is for heat. So when you release heat, when something gives off heat, exothermic reaction. If something feels cool to the touch, whenever something goes through a cooling effect, we say it went through an endothermic reaction. If you you mix some things together and it bubbles and makes a gas, you've now created a new substance. Whenever you see a new substance being formed, that's a guaranteed chemical change. If it changes color, color change is a chemical change. For instance, if you have a piece of metal and you leave it outside and it rains, your bicycle's out in the rain, it's made of metal, and your bicycle chain gets all rusty. It turns orangish, reddish, it's not that pretty gray and black anymore. It's now very dirty and yucky. That color change indicates a chemical change occurred because now you have a new substance when the oxygen bonded with the iron in the metal. If it forms a precipitate. Now this is a new word for a lot of us, precipitate. Precipitate's when you take two liquids, mix them together, and it produces a solid. To help you picture this, let me go ahead and get started. I found a YouTube video that I'm going to play in here for you. And what's happening is you're going to see a mixture of lead nitrate and potassium iodide. When this happens, when they mix the two, let's see what happens. So you've got lead nitrate in there, and you're going to drop in some potassium iodide, and you see that it instantly changes colors. Now in a second, the video is going to zoom in, and we're going to see solid particles are starting to form. You're getting a bonding between the two liquids, and let's just watch for a second. They're going to pour some more in, get a nice yellow color. You can see there's starting to be all these little pieces in there, and they're to the bottom, they're more dense. These are your precipitates. You're getting little solid particles about the size of a grain of sand forming from the mixture of these two liquids. So this is a composite that's used as lead nitrate and potassium iodide. And you see now forming little crystals forming as the two substances bond, and these big chunks are now going to settle at the bottom. Almost looks like a golden colored sand. I think he's going to pour in a bunch more in this section. Now you're going to have a bunch more reaction. You see what's happening is that these two substances and these solid particles are going to filter and drop to the bottom. All right, so that's just a little video on precipitate to give you a better idea. It's when you take liquids, put them together, and you form a solid. Let's go back to our presentation, finish it up with the last few slides. So we just said color change or forming precipitate is a chemical change. What kind of change if somebody tears up a piece of paper? What do you think? Well, it's still a piece of paper. You haven't changed the base structure, so that would be a physical change. You basically change the size and shape of the piece of paper. If you mix salt and water, taking two substances, mix them together, salt water is a solution. It's a physical change because you haven't changed what it's made of. It's just salt mixed with water, but the salt is still salt and the water is still H2O. Now what about if you burn paper? Anytime you have fire or burning, that should indicate a chemical change. And if you think about it, when you burn something, you create smoke, you create like a pile of ash is left, a big pile of carbon. So those are new substances that weren't there before. And if you have a brand new substance formed, guaranteed chemical change. Now if you take that salt water we made in the last step and you evaporate the salt in the water, if you evaporate the water out, you're left with a big pile of salt and the water's in the air. It's a physical change because once again the salt is still salt, the water's still water. You haven't changed what they are, you just kind of separate them at that point. Alright, so that was kind of the overview for it. What I'd like you to do for the next couple minutes here is I have a couple practice questions. I want you to pause the video, read over these 2 questions, and when you're ready for it, go ahead and play the video again and we'll talk about the answers.